Bill.
Hi, everybody, and thanks for joining me today. I'm Bill Culp, Lead Product Marketing Manager here at ANSYS, and I'm really excited about what we are able to do in fluids in ANSYS 18. And hold tight because you're going to hear some exciting stuff today. In today's webinar, I'm going to go through some highlights, and we're going to talk about new packaging that is going to impact everybody who uses fluids. We'll talk about harmonic analysis, overset mesh, some integration with AIM, and simulation apps, another area that I'm really excited about that I think is going to change the way people use simulation. Then after we go through those highlights, we're going to spend some time in each one of the flagship products. So we'll talk about some advances in meshing, Fluent, CFX, and so on. I want to invite everybody after the webinar, if you want to learn more details about the specific advances in these products, to go to the customer portal on ANSYS.com, and there are specific update presentations that go into great detail about each one of these products, and you can learn more about exactly what has changed. Also, go to ANSYS.com in the public area, and we have a whole page on the fluids release highlights, and there's some really cool videos there. In fact, go check out the one on harmonic analysis. I think you'll be really impressed. And also several application briefs if you want to go into some more detail about harmonic analysis and overset mesh. So with that, let's dive in. So first of all, I am so excited to talk about the new fluids packaging. And we have totally kind of revamped the product line for fluids. And all of you who are ANSYS users out there are going to be excited. We wanted to provide the best possible CFD capabilities in simple packages for everyone. We didn't want anyone to have to worry about, do you have Fluent, do you have CFX, which should you use? Because we're going to make sure that everybody gets both packages. And finally, we want to make sure that you get the best of the tools so you can be the most productive and be able to make use of the best and most models as well, so you can do the best fluids and CFD simulation possible. So what did we change? Well, let me talk about the new lineup. First of all, starting out at the entry level, and this is for either those of you who are newer to CFD simulation, or even those of you in larger companies where you have teams of design engineers who may want to start doing simulation. AIM is a great tool for you. It's got a very easy to use user interface that is easy for people who are novices and new users to get up to speed quickly, and yet it has some pretty sophisticated tools. And it also has multiple physics. So if you want to do CFD, you want to do structures, you want to do electrical, magnetics, a lot of cool stuff is in there. Everything an engineer needs to get started. So that's the entry point of our product line. Then I want to announce a new package, and that's called ANSYS CFD Premium. And that's for experienced engineers and people who want to go further and faster with the best validated CFD results across the wide variety of applications. And this package includes both CFX and Fluent, so you have access to both of those flagship products from ANSYS. Then the third new package is CFD Enterprise. And this is the first and only package for large or for sophisticated users, people who absolutely have to have the best, for people in large organizations who need all of the tools to be at your best all of the time. And this includes everything that is there in CFD Premium, but in addition, it includes ANSYS AIM, and it includes a number of other productivity tools to enhance your ability to do great simulation. So let me show you a bit more about what's in there. And this chart also is available on ANSYS.com, so you can check out what's actually in the packages. But I think the most important thing to understand is that AIM is the entry-level product with basic capabilities across a wide variety of physics. CFD Premium includes Fluent and CFX, and also the associated processing, pre-processing, meshing tools. CFD Enterprise includes all of things in Premium, but it also has the specialty tools, such as FENSAP-Ice for in-flight icing. It has Forte for IC engine. And it has Polyflow In addition to that, we have some tools to make you more productive, like Design Explorer, ANSYS Customization Suite to help create and share simulation apps, and Simplorer Entry, which is your starting point for system simulation. So each of those packages are also available in solver-only packages or solver-only bundles, and you can also, like always, buy the ANSYS CFD Prep Post package, so you can do multiple prep posts while your simulations are in solve mode. So you're probably asking yourself, oh, before I get into that, the other thing that's new that I think is really exciting is that we have amped up the high-performance computing capabilities with each of these packages. So we, just out of the box with any desktop computer that you want to run these packages on, you're able to use 4 cores. Previously, the starting point was 1 core. The other thing we've done is amped up our high-performance computing pack. And you may know that in the past, the first high-performance computing pack from ANSYS was 8 cores. Now, if you have a structures package or a fluids package, that the first pack starts out with 10 cores. So another nice little bump there in performance. Now, what hasn't changed? Well, ANSYS Fluent, CFX, Polyflow, we're still delivering the same great performance we did before. Everything should operate just like you had in release 17. The only difference is that it's operated under the ANSYS 18 license manager, and it's part of a larger bundle, so you get more stuff. You have more capabilities, but the performance, the way things operate have not changed. And so I think that it's a great combination of familiarity, but also you get new stuff that you can get new achievements with. The other thing we have not changed yet, and for those of you using our multi-physics bundles, the ANSYS Mechanical CFD or the ANSYS Mechanical Maxwell CFD, those have not changed as of yet. And so those still have the ANSYS CFD bundle, and we are evaluating changing those, and stay tuned. I'll give you more update on that later in the year as we make that decision. So I'm sure you're asking, wow, that's really great stuff. How do I take advantage of it? Well, let me tell you a little bit about the migration paths. So all of you who are ANSYS CFD users have likely already gotten an email earlier this week that kind of announced this change and explain a little bit more about what you need to do in order to take advantage. So all of you who are using ANSYS Fluent or CFX today will be able to receive the ANSYS CFD Premium package. And the migration path is that there's no additional charge associated with moving to this new package. So I think that's a great, really great added value. So you can go from a single Fluent license or a single CFX to having both of those packages, and you can take advantage of both. If you have ANSYS CFD today, you can migrate to the ANSYS CFD Enterprise, once again at no additional charge. And you'll be able to take advantage of Design Explorer and Space Claim and all the other great things in that package that you may or may not have today as part of ANSYS CFD. So how do I get that? You might be asking. Well, first of all, if you do nothing, if all you do is sit back and wait, when your techs and or your leases are updated, when they renew, we will update your license and make sure you get the new packages. If you'd like to take advantage of those new licenses sooner, I would urge you to call your ANSYS account manager, and your account manager can arrange with our support folks to get that license sooner. So if you have any questions about cost, about the migration path, how it impacts any other products, feel free to contact your ANSYS account manager, and they can take you through the process. So with that, let me move over and talk a little bit about breakthrough harmonic analysis. So as you probably know, turbomachinery is the most rewarding, but it's also the most challenging simulation. And there's a huge range of products, and you can see the picture here, everything from a heart assist to a fan to a jet engine. And users continue to demand ongoing improvements. In fact, I did some work on a white paper, and just a 1% improvement in jet engine efficiency is going to get something like $500 billion in benefits over the next few years. And so the economic push is huge. So you have to increase this efficiency and reliability while reducing emissions and noise. And the easy stuff is already done. The easy gains have already been taken, and you need better tools to get to the next level. Well, ANSYS has been working on this problem for many years, and we've been rolling out tools to speed your transient blade row simulations. The flow for every blade in every row has to be painstakingly calculated, and it's really an expensive undertaking. Your time is valuable as an engineer, and computing resources are valuable. And so when it takes a long time, it becomes less economic and less viable. So we have provided blade row methods to perform aerodynamic, aeromechanical, aerothermodynamic simulations in both steady state and transient. And we've rolled out a number of tools over the years that allow you to solve the full wheel with just one or a few blades. And typically these are at least 10 times faster. And people have had a great amount of success for that, but these are time domain methods. And there are certain classes of problems where maybe these are harder to apply, or maybe there's further gains to be taken. So that's where harmonic analysis comes in. Harmonic analysis allows you to solve these blade row problems in the frequency domain. And when you do that, that solution can be up to 100 times faster than solving the full wheel, while that minimizes the hardware requirements and minimizes the time that you spend setting up a simulation. So you can see down at the bottom here, we have two different charts. And if you look at a typical transient mode simulation, it can take up to something like 1,000 iterations in order to solve. Using harmonic analysis, that same simulation could be as few as 70. And you can see that that's 15 to 30 times faster than the prior way. So it's huge. And so in our ANSYS 18, the first release where we think there's a lot of value to be had is in the blade flutter problem. And as you know, as blades heat up, as you get the airflow through the engine, you end up having the blades can move, and you want to take that into account to further fine-tune the simulation. And so that's where we're focusing harmonic analysis today. You can expect to see this technique expanded beyond that in the future. Let's talk a bit about overset mesh. That's another area that we have enhanced and expanded our offerings in ANSYS 18. So when you're modeling flow involving many bodies and with arbitrary motion in your simulation, it can be challenging. You have moving, deforming mesh. It's a good way of solving many of these problems, but it can also be complicated and time-consuming. And there's other ways, or overset mesh is another way of solving these problems, and it could be a way of speeding and simplifying that solution. For those of you who aren't as familiar with overset mesh, you can see the picture on the right, that what it allows you to do is to have a separate mesh for each of the moving items, plus you have a background mesh, each of which can be optimized for that particular product, or that particular object. And then the meshes, what overset mesh does in the solver is it actually connects those cells and drives that simulation so that you can easily account for that motion. So one really cool simulation we did in ANSYS 18 is a store separation. And you can see on the right a rocket. And when that rocket is going at hypersonic speed, one of the things you want to do when those booster rockets are separating is you want to take a look at the shock waves. And with the improvements and enhancements we made in 18, now you can use the density-based solver in Fluent and take a look at those compressible flows and really characterize those shock waves. And that makes a big, big difference. So huge opportunity for improvement. And like I said earlier, overset mesh can simplify these kinds of simulations where you have the structured mesh around individual parts. You might have part swapping. You might have moving cell zones without having to use remeshing or smoothing. And design exploration studies is another area where it's very, very valuable. Now, I've seen a lot of overset mesh, discussions focus around stores separation. The rocket's a cool thing. But how many of you are actually working for companies that simulate rockets? I take maybe not a huge number. There's other places that it can be applied. And let me show you another kind of cool simulation. And this is a robotic arm in a clean room. And in a clean room, typically, you have airflow coming from the ceiling through the floor. And what that airflow does is it keeps particles from settling on the surfaces. And those particles can be microbes, can be dirt that could contaminate what you're working on in the clean room. And typically, the users need to certify the clean room to make sure that it continues to maintain those surfaces. So this is a simulation using overset mesh where we have 5 articulating and translating components on this robot arm. We're looking at the airflow and trying to identify spots of dead air that could be at risk for contamination. So another kind of cool application for overset mesh. Now let me shift gears a little bit from kind of cool technology to maybe the average engineer and even engineers who are less experienced with CFD. I talked about ANSYS AIM being the entry point for our CFD product line, and yet, ANSYS AIM, for all its advantages, it's still starting out and has a more limited set of models. On the other hand, ANSYS Fluent is kind of the best you can get and has the widest range of models and sophisticated materials and all of that other good stuff. So how do you bridge the gap? And our first step to bridging that gap is in ANSYS 18. You can actually use the simple model simplification and meshing tools in ANSYS AIM to prep models for ANSYS Fluent. And on the right, you can see some images of a pipe, and you can actually prepare and mesh that pipe in AIM, and then you can transfer that model to Fluent. And I urge you to go to ANSYS.com and check out another video I have there about AIM prep. And in that video, you might be asking, well, why would I want to do this? Well, in that video, what we're doing is actually preparing a combustor. And a combustor is something where typically the geometry is reasonably simple, and it benefits from the AIM's simple tools, and yet it has complex physics involved, complex combustion. And so you can take advantage of Fluent's depth of combustion research. You can use ANSYS Chemkin Pro reaction mechanisms to make sure that that combustion is as accurate as possible. And yet you've had simple prep and meshing in AIM to set that problem up. Now let me talk about simulation apps. This is another area that I'm really, really excited about. So simulation apps can improve the workflows, speed results, and build best practices for your simulations. Why is that important? Well, as you know, CFD can be complicated. CFD requires a lot of attention to detail, knowledge of physics, best practices, many choices. And for those of you who are experts, you're comfortable doing that. But as simulations move out through the organization to less experienced engineers, how can these folks be successful? And one of the ways of doing that is to build tools that build guided workflows, that build in the best practices, that kind of put under the hood some of those decisions that maybe they don't need to make because we can make them for them in these simulation apps. And so this is a way of really democratizing simulation and yet ensuring that the simulations are accurate and complete. So on ANSYS.com, for those of you who haven't looked already, we have an app store, and we have many simulation apps there, hundreds of them. Many of them apply to fluids. and it's a way of benefiting from our ecosystem. So some of those apps are created by ANSYS developers, who are the same people who develop our software. Some of them are created by our ACE support team, and these are the PhDs who provide support and expertise around around CFD for you. And so they create apps. We are adding apps from folks in universities, from consultants, from our channel partners, all across our ecosystem. People who are finding value with simulation are putting that value into ACT templates, into simulation apps, and then making them available. And so that allows you to benefit from the expertise that the rest of our organization has developed. So those of you on CFD Enterprise, you will have the AC or ACS application, which allows you to actually build these apps. And one of the things you might want to do if you're one of those experts in a large company is you could build, using the ACS application, you could build some of these simulation apps and then use that to have a guided workflow for your design engineers, say, to do a simulation earlier in the product development process. Let me show you some examples of what these apps look like. The first one is a virtual wind tunnel application, and this one is in ANSYS AIM, and it allows you to very easily and simply walk through the process of doing external aerodynamics. And some of the examples here, you see a football in flight, you see a spoiler wing on the back of a car, you see wind loading on buildings in a city. And so very cool stuff, and it's very quick and easy in ANSYS AIM. Another example is this example in ANSYS Fluent, where we're actually characterizing a blood vessel. And what you can see here, there we go. You can actually see the workflow here. We're loading a model of a blood vessel that probably was acquired through a CT scan or something, where the model is allowing us to choose the entry and exit, set all the parameters, and then it's going to give us a report about the pressure drop in that vessel. And this might be interesting for diagnostic work in healthcare. But notice how easy and fast this was. There was no explicit work done with meshing. You didn't have to worry about all the volume extraction, all the other stuff. The ACT simulation app did that for you. Another one that this is for those of you who are doing really large models. We launched native polyhedral meshing in ANSYS 17. Great stuff. But it was only available in Fluent meshing. And many of you said, oh, Fluent meshing is okay, I like that, but why can't you make it available in Workbench meshing? Because Workbench meshing is the tool I would prefer to use when I'm setting up models for simulation in Fluent. Well, now using a simulation app, it's easy to do that. So what this simulation app does is allows you to set up the problem and get the meshing started in Workbench. Then basically you just invoke the app, which the app does all the work of going to Fluent meshing, getting that native poly going, and then automatically transfers the model to Fluent for solving. You don't ever have to work in two environments. You're only working in the Workbench meshing environment. So it kind of simplifies and speeds the process and makes it easy for you. So that's kind of the power of simulation apps, and you're going to see many more of these rolling out over time. Now, let's go into some of the details of specific products and some specific updates, and we'll start with meshing. So I'm going to talk about, first of all, I should say, overall, the story of meshing is you really can have it all now. We've always been known for accuracy in ANSYS Fluent and ANSYS CFX, and now we've been spending a big focus on improving the speed and usability. And as you saw earlier, that ACT app ties these tools together, which is a great thing. So ANSYS 18 is making it easier than ever to get great results using CFX and Fluent by speeding and simplifying your meshing and model preparations. So, over the last few releases, we've been able to reduce the pre-processing times for complex geography or geometries by 40 to 80%. And that's just the cumulative value of the various improvements that we've made over time. And I don't have a specific slide on this. I probably should have, but one plug I want to make is in the new packages, we have the ANSYS Space Claim Direct Modeler tool. And so all of you will have access to Space Claim now in the new packages. And that is a really, really exciting capability for those of you who have not used it yet, to really simplify and speed and just, it's a joy to use as you prepare models for meshing. So put in a plug for that. That will make a huge deal for all of you as we go forward. So here's some improvements in ANSYS Fluent meshing. As you can see in the beginning, across the board, we've made enhancements in the various processes. Hexacore 3 times faster, stitching up to 10 times faster, meshing 10 to 30% faster. These are going to make an impact for you with smaller models, but an especially big impact for those of you doing really big models that take significant periods of time with maybe multiple time-consuming steps. It'll make a big, big difference. So I mentioned native polyhedral mesh generation. Wrapper technology is getting better. CAD assembly method management. For those of you who didn't already know, we can now import CAD models with the CAD tree intact. And so now you can much more easily go back to swap that model back and forth to the CAD system without having to rebuild those models. And then more automated. So there's a lot more API work done with over 100 functions that are scripted. What's new in ICEM? You get more control. So there are a lot of local controls that really give you an opportunity to do a lot more with a lot more detail. So I'm not going to go into a lot of detail on each one of the individual ones. The presentations on ANSYS.com on the customer portal go through in much more detail what each of these individual ones are. Another area that's good, though, better integration. So Space Claim can import these files, and also we can connect to ANSYS Mechanical directly as well from ICEM. And finally, ANSYS Meshing, another area where we have much more local control. So you can see some of the details here about the improvements there, and it's also faster. So the proximity size function has been improved significantly, and we're able to do that 30% faster than we could in the past. Now let's move on to ANSYS Fluent. Some of the details there. And what I want to start out with, once again, is a better user experience for everyone in ANSYS Fluent. And we've done many things, almost too many things to go into detail here, but continuing on what we did last year with the new user interface, many enhancements that just add up to a better experience, a faster and an easier experience for you. At the same time, we've been focusing on robustness. So we've been focusing on ensuring that your simulations converge, that you get the results the first time. So let's talk a little bit more about speed. We continue to improve scalability. Not only do we have the speed record with hundreds of thousands of cores, but we also have been improving the setup times. You can see here, so nose-based gradients have been optimized. And so this aircraft wing benchmark is 3 times faster when you're using 1,000 cores. The sliding interface scalability we enhanced again. So this F1 racing car benchmark is 3 times faster at 2,000 cores. So we'll continue to chip away at this and continue to make improvements. And this is just to say, too, that this is in the realm of, many users are in the 1 to 2 to 5,000 cores, and we're focusing in those areas, not just at the 50,000 or 100,000 cores. Here's another example that everybody can see. So our HDF compression, reduces the file significantly. Used to be, though, that the conversion process was significant and it could be slow. And now we've improved that benchmark, or improved that data write time and read time significantly faster, and another way of improving your experience. Here's a new model, the Corey model, to accurately simulate water-oil displacement. And this is typically used in reservoir production in oil and gas. Additional physics here as well, advanced compressible multiphase for high-pressure injectors. Another nice improvement for you, another new model. Here's some improvements in discrete phase particulate flows, and we've enhanced that as well. A lot of improvements, since we had the acquisition of Reaction Design a couple of years ago. We've been integrating back Reaction Design mechanisms and combustion tools into Fluent, and you can see we continue that process here. So there's a number of accuracy improvements, speed ups that are using reactions from ANSYS Chemkin Pro, and you can see that those improvements in combustion. Here's some more improvements for automotive headlight applications. So our Monte Carlo radiation model is released, as well as some solar ray tracing parallelization. So some speed ups for that as well. And then our adjoint solver. And this is a great tool because what it does is it allows you to do automatic shape optimization. You can see the heat exchanger here as we do that optimization. What we've done is we've added support for rotating reference frames. The other interesting one is conjugated heat transfer, and you can see some nice new capabilities there that further broaden the range of applications for the adjoint solver. Let's move on to ANSYS CFX. Oops. So beyond harmonic analysis, we are now supporting flank milled blades, and this is an area, new manufacturing process that is gaining ground in automotive turbochargers and industrial compressors. And so now we can directly in Blade Modeler support that process because the flank milling delivers a slightly different profile than the traditional milling techniques. And so now we can automatically deal with that profile as you use Blade Modeler. And so it's consistent geometries represented for all the tools. And so it allows you, those of you doing flank milled blades, to directly model those in CFX. We're able to continue to reduce or improve fidelity and robustness. So we can import CAD models directly now into TurboGrid and Blade Editor. No more recreating those models. And so it's further productivity improvements for you. And one particular area that's interesting when we CAD import the fillets versus having to reconstruct those. And it gives you the exact representation, high quality, and further simplifies the process for you. Another cool area is in CFX is we're able to now account for actually movement in the hub or shroud when you're doing your aeromechanics. So when the blades are fluttering, it used to be you could only account for the blades. Well, now if that blade flutter also impacts the hub or the shroud, we're able to handle that in ANSYS 18. This is also tied in with harmonic analysis and the harmonic analysis release in 18. Here's capability. You're able to actually monitor the live output as you're running in CFD post in CFX. And then here's another way of taking a look at plots, live plots. So the polar plots and the cyclic plots improve the insight. So now you can do a better job of judging whether a quasi-steady periodic state has been reached, and just another way of watching and monitoring. Now let's move on to ANSYS Polyflow. And there's been a number of enhancements here, and one area is thermoforming for non-isotropic material. Sorry, I moved on there. And you can see one example of that is forming the hard hat. And when you have a reinforced polymer sheet, so you have some fiber, you can, say some metal or fiberglass fibers or something, you can actually see the distribution of those fibers as the hat is formed. This is also something we can do in tires. So another interesting new capability for Polyflow. You can stop and continue. Another, at the end here is an interesting one. We have added actually I should go to the next screen really for this one. We have added Polyflow capabilities for extrusion to ANSYS AIM. And so for simple basic polymer extrusion, now you can use the simple user interface of AIM and the template capabilities, and it's easy to stop and restart and all those kind of good things. And you can expect over time we'll be rolling out additional Polyflow capabilities in ANSYS AIM. Let's talk a little bit more about combustion tools. And so we continue to enhance those tools as well. ANSYS Forte is our IC engine solution, and we continue to enhance that. So we've optimized simulations for faster IC engine analysis. So right in ANSYS 18, we're using 50% less memory with better parallelization. There's less mesh dependency for flame propagation, so you get more accurate results. And also we've improved conjugate heat transfer. And so this continues the integration of our tools. So when you integrate Fluent with ANSYS Forte, now you can model the engine cylinder liner wall with a moving piston and get better heat transfer analysis. ANSYS Chemkin Pro, we've enhanced that with 20% faster than the transient solver. There's a new pressure-dependent rate formation. And we also have a link now where they can import results into Gamma Technologies GT Power. And so for those of you who are GT Power users, you can now integrate with our solution. Let's talk a bit about ANSYS FENSAP-Ice. So FENSAP-Ice is our in-flight icing solution. And as part of the repackaging going forward, we have now simplified ordering FENSAP-Ice. In the past, there were many modules, and you kind of had to go through this smorgasbord of options and had to pick from a long menu to make sure you got the right stuff. And it got a little complicated, but now there is just one product called FENSAP-Ice, which includes the old turbo module, the pre-post processing, OptiGrid, which is the optimized meshing tool. It runs on the ANSYS License Manager and uses ANSYS High Performance Computing. So this is available standalone, and as I said earlier, it is also available in the ANSYS CFD Enterprise bundle. Those of you who have FENSAP-Ice in the old structure, please contact your ANSYS sales team or your account manager, and they can walk you through the process of migrating to the new license. Some enhancements. We continue to improve FENSAP-Ice and its performance. So now we can do much more integration where icing can be done in ANSYS Workbench. There is a new roughness model that has now been imported to Fluent. There's better documentation and testing, and additional modeling advances in FENSAP-Ice, so we continue to make it better. So automatic remeshing for ice growth, turbomachinery crystal reinjection, and just so on down the list. Lots of good stuff. Let me tell you a little bit finally about ANSYS AIM Pro. Because with every release, we're releasing new capabilities. And I'm going to focus here on some of the new capabilities for fluids. And so we've added additional heat and momentum sources. We've calculated value monitoring, periodic interface and automation, non-Newtonian viscosities, wall roughness. And over the next few releases, you'll continue to see additional capabilities rolled out in ANSYS AIM. So I hope that you're as excited as I am about what you have seen in ANSYS 18 for fluids. learn more at our highlights page on ANSYS.com, or as I said earlier, we have very detailed update presentations for each of these products on the customer portal on ANSYS.com. You can go in and learn more about all of those line items that I just didn't have time to go through in much more detail here